Welcome to another video from explainingcomputers.com. This time I'm going to set up a battery-powered Raspberry Pi Zero so that it can water some plants and take a time-lapse video of their growth. So let's go and get started. Right. Let's begin with a rundown of the hardware for this project, which starts with this, a Raspberry Pi Zero, which I've currently got in a Pibo case. I think I'll probably take it out of the Pibo case as things progress, and it's currently got an indicator LED on a header plugged into the top there from my Raspberry Pi battery testing video a few videos back. This might be useful as well in this project. And before anybody asks, I could use a Raspberry Pi Pico microcontroller to make a watering system, but I've chosen to use a Raspberry Pi Zero because it's got a camera connector, and so it can handle the time-lapse photography part of this project as well. Next, to enable this Raspberry Pi to supply water, I've got one of these, a 12-volt normally closed solenoid valve, which is the kind of thing you use to turn water on and off in, say, a washing machine or a water dispenser. And specifically, as you might be able to see here, this is an FPD270A, which is a pretty generic component. Mine cost me £8.89 on Amazon Co UK, but there's lots of very similar solenoid valves around, and on Amazon.com I found one for $12.99. And of course, I'll put links to solenoid valves you might wish to use in a project like this in the video description. Next, I'm going to use one of these, a Raspberry Pi relay hat, to control the solenoid valve. Specifically, this is the relay hat I used in an earlier Raspberry Pi automation video a few years ago, and ideally I'd have a 2 relay hat rather than 3, and I'd have one which fitted directly on the Raspberry Pi Zero without overhanging, something like this $12.99 model. But this board will work fine. It's just a bit bigger than the Zero, but I can cope with that in the design of the project. And these relays can switch up to 30 volts at 5 amps, which is perfectly sufficient for controlling our solenoid valve. Moving on, I'm going to try out this resistive moisture sensor, which I got from the Pi Hut, which will open up with Mr. Scissors. Let's get inside. There we are, with some bits in here, various parts. There's the moisture sensor itself. This is going to go into a pot so we can sense the moisture in the soil, get rid of that bit there. And then there's a little comparator board here and wires to plug things together. And moisture sensors can be resistive or capacitive in nature. And this resistive one is very easy to use with this comparator board because you just plug it together and it gives you a digital high-low output. So all we need to do is to adjust the potentiometer here to the point where we've just got enough moisture for our plants, they've got enough water, and we can get a signal to the Pi saying whether the plant's got enough water or not. This said, it is worth noting that resistive moisture sensors can be problematic because they can corrode very easily, but I've got a cunning plan to try and stop that happening, which I'll tell you about when we get to that point in the video. Moving on again, to record nature in action, I'm going to use a camera connected to the Pi. It's going to be this Zero Cam for the Raspberry Pi Zero, which comes in this rather over-the-top box, but hiding in there somewhere is the Zero Cam. That'll connect to our Pi, which will enable us to record a time-lapse video. Finally, I'm going to use this NP7 12-volt lead-acid battery, which can power the solenoid valve directly and which will connect to the Pi Zero using this buck converter, as I covered in my recent Raspberry Pi battery power video. And so here we are, all of the electronic, electrical and computing parts we need for this project, so it must now be time to get them working together. Greetings, here I am back again, and I thought I'd test out the moisture sensor, which as you can see I've got connected up to its comparator board and through to the Raspberry Pi Zero. And the wiring here is very straightforward. I've just got 3.3 volts and ground on the Pi connected through to the comparator board along with a GPIO pin. And as you can probably see here, the Raspberry Pi Zero is connected up and running. An LED has come on the comparator board. That has to be a good sign. So let's go across to the Raspberry Pi desktop. Here we are, where I've written some test code in Thonny. And this is a very simple bit of Python. Initially it just imports a few libraries for time and GPIO, and then it sets GPIO numbering to be board, and it sets GPIO pin 29 to be an input. And then beneath that we've got a while true loop. While true is always true, so this will be an infinite loop, and what this does is to say if GPIO input 29 is a 0, it'll print wet, else it'll print dry, and then we've got a time sleep command for 0.25 seconds just to stop this loop going completely manic. And then everything here is contained inside a try finally combination. There's try up there, it'll go through that lot, but if we crash out of this using Control C, it'll always execute finally, which in this case will clean up our GPIO pins. So let's execute this code by running it up there, and we'll give ourselves a bit more space to see the output, which will hopefully appear in a second. There we are, it's printing dry, running up the screen like that. So let's go back to the moisture sensor, and let's just bring in, for example, a glass of water. Don't normally bring one of those next to a pipe. If we put that in there, oh look, it's wet if we put it in the water, and it's dry if we take it out of the water, and wet and dry. So that's potentially useful for sensing moisture. But let's give it a more hard test than that. I've got over here two little pots. There's pot number 1 and this is pot number 2. And pot number 1 has got dry soil in it. Let's stick the moisture sensor in there. Well, it's still dry, nothing's happened there. But moment of truth, what if we go into the wet soil? Oh look, the wet soil is wet. So there we are, we've proved we can use our moisture sensor to detect the difference between dry and wet soil, and we can use that in our Raspberry Pi watering system. Right, here I am back again, and I've now put the relay hat on top of the Raspberry Pi Zero, and the relays on this hat are controlled through pins 37, 38 and 40. But there is pass-through on the GPIO connector here on the relay hat, so I've been able to reconnect the moisture sensor. And as you can probably see, I've also connected in the solenoid valve. It's getting very exciting here. This is connected in to be powered from the battery. The leads are just looped via the buck converter, which also will be powered by the battery. And this will be switched using the first relay on the relay hat, connected there to its normally open contacts. So it'll be turned on in theory when the relay is closed using the Raspberry Pi. So let's go across to the Raspberry Pi desktop where I've made a few changes to our code. This is now a piece of test code to test out the solenoid valve as well. Same libraries come in. Only thing different here is I've set up GPIO pin 37 as an output to control the relay, which will hopefully switch the solenoid valve. And in our little test loop, it's not just going to print things out, it's also going to turn the solenoid valve either on or off. And this is of course not exactly what we'll do in the final code, but it's good enough for test purposes. So let's just run this code like that. We'll give ourselves a bit more display there to see the output. Everything is dry at the moment. Oh, just sorting itself out there. Anyway, let's just go back to the bits of hardware, and if I take the moisture sensor, if I now put this into the water, it should make the relay trigger. So hopefully you can hear that. And there's also a little LED, you might be able to see that coming on and off, so I know that the relay is triggering. So what I'm now going to do is to connect power on the battery, which means in theory, when we now trigger it, it'll also trigger the solenoid valve. And again, all we can do is hear it because you can't see anything happening here, but in theory, yes, there's quite a kick when this releases. Can't really hear it going on, but definitely the solenoid valve is triggering. So we've progressed, we've got more things working as we head towards our Raspberry Pi watering system. Right, I told you I had a cunning plan to stop the moisture sensor corroding, and it's this, 2 yellow wires. And what I've done is to disconnect the power going to the moisture sensor comparator board here from the Pi from 3.3 volts, and I've looped it through the second relay here. Ah, you cry, this means we can turn the moisture sensor on and off. We only have to have it on, only have to have power going through it when we need it, and that'll reduce its chance of corroding. That is the idea. Now, if we go across to the Pi's desktop, I've also made some changes to our code. This is more like the final code. I've even called it Watering Pi now. And what I've done here is first of all to add in a GPIO output to control the second relay to turn the moisture sensor on and off. There we are. And I've also set up a couple of variables here called interval and water. And interval is going to be the period of time that Pi waits before checking to see if the plants need some water. And here I've set it to be 5 seconds, but it'll be more like, say, 1800 seconds in the final version of the code, something like half an hour. But of course I've set it as a variable so we can experiment with it, get the right value. And we'll also have to experiment to get the second value here, which is water. This is the period of time that the solenoid valve will open to let water through to water the plants. And I've realised the valve I'm using is designed to take mains water pressure, and the amount of water it lets through is in some senses proportional to that pressure. So we might have to open the valve for quite a reasonable period of time to let through a small amount of water to water our plants. Anyway, we can play with that later on when we're setting things up. Anyway, down here we've now got another try finally loop, and this, as I say, is a bit more like our final code. Dear me, I'm whizzing all over the place. Anyway, what it basically does is first of all to turn on the sensor and allow it to settle, so it turns on the second relay, waits for a second so electronics can settle down, and then it checks to see if the sensor is dry, and if so it opens the solenoid valve, waits for the time defined in the water variable, and then closes the valve again to obviously close the valve. And then at the end of that we then turn off the sensor, waits for the period of time interval, and then everything repeats. So let's now run this code. There we are, and we'll go across to the shot of the relay board, which I've got slightly dimly lit so you can see hopefully its LEDs, which as you can see are coming on. And what is going on here is first of all it's turning on relay 2 to activate the sensor. There we are, checking if it's dry, it is, turns on the solenoid valve, turns it off, waits for a period of time interval, turns on the sensor again, there we are, waits to see if it's dry, turns off. But this is because I haven't got the moisture sensor, which I've got somewhere over here, haven't got that in the water. So let's put it in the water. It's now obviously wet, so when we get the cycle going through, it'll turn on the sensor, just turns off again, turns on the sensor, just turns off again, turns on the sensor, just turns off again, there we are. Take the moisture sensor out of the water, turns on the sensor, finds it's dry, turns on the solenoid valve, and then it gives it some water if there was some water coming out the solenoid valve. So you can see the principle is working here. We're heading towards a working watering system. Guess what? Lots of things have now happened. For a start, I've mounted the Pi 0 in the relay board to a baseboard and secured it to a post at the back of this makeshift rostrum. And I've also wired the Pi 0 into the buck converter, which is now down here, so everything here is now battery powered, although I've had a problem with one of my battery terminals, but do not fear, everything is working just fine. And so the wires coming out of the contraption here going off screen somewhere, these are just for the HDMI connector, for looking at things on the monitor in a second, for testing purposes, for coding purposes. We've also got a connector here to USB to a keyboard and a mouse at the moment. Those will disappear as this thing becomes a completely headless setup. And down the front here, I've got the solenoid valve, and the idea is there'll be some sort of tray down here. You have to imagine a tray down here. It doesn't exist at the moment, but there'll be a tray down here in which pots of plants will sit, and the solenoid valve will deliver water into that tray to keep the plant all watered and happy. And the only reason I'm not showing you the solenoid valve in operation so far, actually with water going through it, is that I've had great difficulties getting hold of some flexible plastic pipe to connect on here and take to a water supply. So fingers crossed that plastic pipe will arrive before the end of the video. Since I saw you last, I've also added the indicator LED to the Pi 0, which connects to GPIO pin 7 and via its current limiting resistor to a ground rail. And I've also added the zero cam camera on this little wire mesh support so it can be angled to look down towards the plants. And I've adjusted the focus on the camera so it's as close as it can be in terms of focusing. It might still be too close to the plants though. I might have to use a different camera with a longer ribbon cable to get a bit higher up, but this camera at least will be okay for now for testing purposes. If we go across to the code, you'll see I've also made some big changes here in software land. For a start, I've imported the library for the Pi camera, and I've also set up GPIO pin 7 as an output to control the indicator LED. And then beneath that I've set up the camera, defining camera as pi camera, setting the maximum resolution and the frame rate to 15, which is required to actually access the maximum resolution. If we go down to our variables, I'm now defining interval in minutes for reasons which will become clear in a second. I've currently set it to 0.5 minutes for our test here, and I've also defined pic number, which will be used in capturing our sequence of time-lapse images. We then go down to our loop. This is also changed. For a start, we turn on the LED at the start of the loop when things are about to happen. We then turn on camera preview, as well as activating the moisture sensor, and we have a time sleep of 5 seconds because it takes the camera quite a time to settle. We then go on down. The rest of the code there is the same as it was before, but now at the end of it, we've then got the camera taking a picture, which it's going to save to home pi pictures, and it's going to use the picnum variable to label our frames. We then stop the camera preview going on, which will save some power. We increment pic number to do the next number on the next part of the loop. And then after that, we've got our waiting for our interval period, which used to be a simple sleep command, but it's now a bit more complicated. I've basically taken the code from my battery testing video. So we're flashing an LED every 30 seconds. So basically this flashes the LED 3 times at the start of every 30-second period. And it goes through this loop while the count here is less than interval times 2, which here will be interval times 2 will give us 1. So in this test, it'll go through the loop 1 time. But normally I'm going to be setting interval to 30 minutes, but I want to see an LED flashing away just to show us the device is working, and that's what this code is going to do. And then at the end, things finish off just as they did previously. So let's run this code, and we'll bring up a shot of the board so you can see the LED turning on as the code executes. There we are, hopefully you can see that. And we've also now got on the screen here a preview from the camera, which is brought up so it can take a picture. So you get a little picture of the pot there. That's now a picture's been taken, and it's now going to do a flash the LED as it is, and then it'll wait another 25 seconds and repeat the process. So we'll let that go through. Got some warnings here coming up for GPIO because we haven't tidied up GPIO before I started this. Never mind, doesn't matter, won't stop things happening. Hopefully in a second we'll get to end of our 30-second period. I should learn to play the harmonica to give you music at moments like this, but anyway, we will wait in real time for the thing to start again. Shouldn't be long now. Come on, Pi. There we are. It's brought up a preview again. It's going to go through the process as it did previously, checking the sensor. If it's not got moisture there, it'll open the solenoid valve, etc. And then finally it'll take a photograph. There we are, it's done the thing. And I'll close that down. And the reason I've done that is so we can open up the file manager here. There we are, and I'll go to pictures, which is where I'm saving the pictures, and you'll see we've got 2 pictures from what we just done. And if we open one up, you'll see we've got picture 1 is one of the pictures we were just looking at. So you can see we've got everything set up now for the Pi to water some plants, but also to take a time-lapse movie. And so I think it's now time to move all this equipment to my greenhouse to set it up hopefully with some plastic pipe and to see if it'll work in practice. Greetings and welcome to my rather dilapidated greenhouse where I've got everything finally up and running. I have switched the camera over to the other Raspberry Pi camera I've got along a ribbon cable to try and get a better shot of the plants in focus, and even so I've had to move the plants a bit further away from the rostrum, which is a shame, but at least that will now work. And I've got the valve connected up, I've got it connected to a makeshift water supply, my plastic pipe arrived. Everything here should be in working order. In the code, I've set the interval between testing for moisture and releasing water and taking a picture to 15 minutes, and I've set the water release time to 12 seconds after quite a lot of tests. And I've also removed the spurious brackets that for some reason I put in around many of my GPIO commands. No idea why I did that. Obviously my mind was going off somewhere completely different when I wrote the code earlier, but everything is now working fine. So I'm now going to start things off. And as I do so, I'll give you a shot of the plants in my little tray. And as you can see, what we're going to grow is cress. I've got some cress there growing quite well already, some cress just germinated. I'm taking these out of the tray just for now so you can see what's going on. And I'm going to take the moisture sensor out of that little pot. So in theory, we should get some water release when the Pi gets that part of the code. There were a few drips going on there from various earlier tests, but this should now be working. So we wait a second, the Pi should release some water. And there we are, we have a slow release of water into the pot. Doesn't put in much in every time, but a bit has got in there. You can see the principle. So what I'm going to do now is to put my moisture sensor back into these plants because they are already quite moist. I'll put that one in there. We'll put these little tubs back in here. I'll get a bit more water in 15 minutes. It'll slowly fill up. Don't want to overwater these plants, says he, not being an expert gardener at all. Anyway, I'll now leave the plants there, and in theory this is the shots the pie can see of them, or the magic of filmmaking, and I'll leave this for a period of a few days and we'll come back to see the results. Greetings! Here I am back again. It's now about 3 days later. I started this experiment about 1 PM on Monday. It's now about 2 PM on Thursday, and as you can see, the cress has grown rather substantially. And it seems the watering system has worked very nicely. The water levels remain consistent throughout. I did start to panic about 8 PM on Monday evening. I came out, thought it was flooding. It wasn't. I tried to manually remove some water. I knocked the pots. That'll be bad for the time-lapse video. I think I've learnt the best thing is to let the pie get on with it. Anyway, this has all worked as far as we can see here, but I'm also very interested to see if I've recorded a time-lapse video, so let's go inside and see what's on the pie's micro SD card. And here we are looking at the first frame the pie recorded, and the good news is it recorded lots of other frames, so I have got a time-lapse movie to show you in a second. But just before I do that, it's worth pointing out that some of the frames the pie recorded were corrupt. They looked like this, and this, and this, and some frames were recorded in such a corrupt fashion they couldn't be read at all. And of course, there were a lot of black frames recorded by the pie because it was night time, and so I've removed all the black frames. And so, of the 274 frames the pie recorded, the final film I'm about to show you is made of 132 frames, which I'm playing back at 12.5 frames a second. And there we are. We've seen the cress claw its way out of the ground. We've seen biology in action. Certainly there are various issues with this time-lapse movie. It's not the best time-lapse movie in the world, but it has made me eager to do more with the Raspberry Pi doing time-lapse photography. So I think I'll be making another video all about Raspberry Pi time-lapse photography in the future. But anyway, for now, I think we should look at the movie again, this time with some background music. So there we are. We've set up a Raspberry Pi Zero so it can water some plants. And I suspect it's already a better gardener than I am. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe. And I hope to talk to you again very soon.